Let us do so. Let us see practically what we just discussed. So let's close again the UART command example. Let's take it out, and I propose to re-import it to, even if very fast, to show basically to show how it is, to show how to import again. Of course, it is something very important. Let's see on the .ioc file. Again, here it is super easy. We don't have very complicated like commands that we have to take care of. I've implemented like just a command to turn on and off this LED, like we did in the first example. And I am implementing the UART, which is already enabled by default. The only difference here is that actually, oh my god, here I have enabled our interrupts, our interrupt. Okay, so if we go again, check again on the system core on NVIC, UART to global interrupt enabled. Then after this, the only other thing that we can check is the low power, the voltage regular scale, and we put it to voltage 2, which means, again, as I showed, I think it was the first example actually, you have to lower the clock. In this case, I don't need a lot, like a very fast clock. I just put basically 2 megahertz in total, which is still rather high if you think about it for this kind of application. But I just did it by changing a number, so it was worth the effort, I guess. So, in fact, also here we are using, as we were saying before, a low power mode. I mean, in this case, we will stay basically all the time in stop mode, actually, in sleep mode, yeah. Actually, maybe here we could go to stop mode, actually. Yeah, I am pretty sure we could go to stop mode, because we are not using anything super fancy. I know, yeah, no, maybe we can't still. If we were using the low power UART, then yeah, we could go to stop mode. Because again, most of the peripherals are off if we are using stop mode, except like the low power ones, and then there are some other exceptions. I should double check whether or not it is possible. Eventually I will try after I show you this exercise, and if it is working I will keep it inside the video. You will know if it's working or not, because if it doesn't work it would have been cut probably. So again, super easy. Only thing that is like of interest, I mean, actually it's pretty much all new in this case. So what do we have? We have, first of all, a transmission and reception buffer for the UART, and we are just saying, okay, this is the space of memory in which I will throw the bytes that I want to send to the computer from the microcontroller, and this is the buffer in which I will throw the bytes when I write characters from my computer, and where I will throw them inside the microcontroller. Okay, here you see that we have some definitions of some commands. In this case, in order to make the things relatively more straightforward, I am using a different command for turning on, like LED on and LED off are 2 different commands. You could make it, I strongly suggest you to try and make it different, like in 2 different cases, like you have a single command LED and the option on or off. It is not much different, you just have to change the function for maybe LED on or LED off, and that's it actually. So yeah, try it actually if you can. Okay, here we have a definition for the possible machine states. In this case, for of course for the UART communication, and we do have and that's it actually. I think, yeah, I have a command index in which I store where we are currently in the command. So if I send the first command index will be 1. If I send the second command, it will be 2, and so on. If I send a new command, I want to start fresh, so this should go back to 0 eventually. The UART status is start. And what do we do in start? In start, let's go in the moment just in the main. We are just starting the reception, and then we are going to a UART receive status in which we are just receiving. If you are in the UART receive status, we can go to the low power mode. If we are, then we have a reboot status in which we stop the reception and we go back to a receiving status. Okay, fair enough. Then we have a function. This is a callback UART rx half complete, in which basically whenever I receive one character, I go here and I check what character it is. It will save it automatically. So I am doing this after I save the character, and I'm checking if the character is good. If it's not good, then I can just if it's good, okay, I am saving it and continuing. If it's a return character, I am beginning processing the command. If it's a backspace character, I am going back. So I'm deleting a character, that's it. If it's too long, the command exceeds the maximum size, I'm giving an error. Of course, this should not be a problem, ideally, because I'm putting the maximum size inside when I start here the reception, but I'm just putting this here for good measure. And then if we receive a return character, we can finally process all the commands. You can see that when I process the command, I am receiving good or bad. Okay. If at least one command was good, it means that we succeeded. So that's why I'm doing it with and equals. So 0 and 1 is 0 by definition. The logic operator and sorry, it's not this. That's it. Actually, that's it. Okay. Let us see. Yeah. As regards for each command processed, or in this case, all of the functions that check the commands are for each command, of course, are the same. I'm just checking if the head of the command is correct. If it's not correct, then I say okay, it's not correct. This bad syntax is actually in this case garbage, because in this case we go to check the command if we receive the \r, and that's it. So it's actually also maybe a bit useless, but I kept it just for good measure again. Yeah, and then in this case we transmit an hello world, like the classic ping pong command. We have also, I mean, here we don't have a way to send time, I guess, but okay. And then we have turn on the LED and turn off the LED. I said before, sorry if maybe I'm jumping a little bit, but I say that I am calling this call, I have this callback for when I receive characters through the UART. You can see that this function is actually not called anywhere here. Of course, this function is called, in this case, here. UART rx half complete callback. You could tell me, yeah, this is actually if I have to be like 100, like 1000% like accurate. This name is not mandatory. Actually, it could be a little bit confusing because there is a default callback that is used sometimes. That is basically this one that you have to enable through some flags. But I don't care. Eventually, yeah, I guess eventually in the function I will in the files I will give you. Maybe I will just delete this one and enable the flag. It is just working the same, so it is not a problem eventually. Okay, that's it. We can see what happens if we run the command. Maybe it is interesting to take a look at the current state. I know we will not be able. Maybe if we go, okay. I of course remove all, and we can also take a look. Eventually, the command index could be interesting. And also rx buffer. We can see eventually okay, here we can see eventually what is the currently received character eventually. Okay, so I can write, if I write a, and of course I need to start the program. Okay, if I write A, you see that I sent one character and the buffer says, okay, I received A. B, C, D. Is this a command? No, the command does not exist. If I say hello, sorry. The command was hi. It says hello world. It's kind. If it's in ping, it will send pong. And finally, LED on turns the LED on, LED off turns the LED off. So yeah, it is easy things. Maybe if you think about it, it is, yes, you can say it is relatively easy. The implementation is maybe not too immediate, okay, and it's still super, I feel it's still super useful. So yeah. If I go sleep mode, it will also work, of course. I can show you in a moment. But meanwhile, I can show you also, if you want to, we can, if you really want to, we can look step by step what is going on. What do you say? You are not, okay, of course, you are not, of course, you don't have a choice. It's me that is a recording, so yeah, you can skip. Don't. Yeah. So initialize. Then we go. We transmit again our welcome message. You could see that when I pressed the button, it took a little bit longer than before. This is because of course, when it's transmitting here, it is doing that since I'm doing that in polling mode basically, which means that it's the CPU that is speaking directly to the device and the device only. It doesn't do anything else. So if anybody else tries to say, okay, I need help, you cannot interpel another device in polling mode, but you need an interrupt, of course. Okay? But in this case, we only have the UART running. So it is the most, usually you want to do in polling sometimes, maybe like the most important thing. So it is the only thing, so it is automatically the most important. Okay, we are beginning from UART start. In fact, here we are not having anything. If we were to write, we are not receiving anything, because of course the UART was not received at all. You can see that I press the button here and it's not doing anything. I'm going over, and I'm going to the receive status. If I press a button, if I go step over, actually, eventually, it should go on the .it. I guess I should. I guess I can put a breakpoint here, so to show. Okay. Oh well, it's not doing that. Fair enough. If I go with pause, okay, now it's doing this. Yeah, sometimes it can be a little bit quirky, I guess. But yeah, you have, of course, sometimes you can have some strange errors that don't make sense. But in that case, you still. That is, I need to scare you. Of course, this is it's standard practice. You, of course, you are like the one that is programming. You are not like the end user. So it is up to you to make everything work super nice and clean. Otherwise, a customer, your friend that you're doing this project for, yourself will be very like angry. It will say, "Oh no, give me money, give me back the money." I don't know. If your friends ask, if you ask your friends money for doing something easy, of course you should not. Maybe, but it's I don't know. Okay, no, jokes aside. Well, yes, I can show that it's working with the power sleep mode. Yeah. Okay, and then if it's working in stop mode, it can be cool. Yeah, sorry, I forgot to delete the other backslash. All right. It's working, as expected. Okay, let me call the stop mode, which is in the PWR power. Okay, here the syntax is pretty similar. I have to say, okay, low power regulator on. This one, for the syntax of the other one, it's not the same, so you have to check on the documentation here. And it's we are using PWR stop entry, wait for interrupt, WFEI. Okay. Keep in mind that I am putting this kind of functions here. I can receive it, IT, abort receive, etc. And the stop mode, especially in the while loop. Okay, this, in fact, it could be a problem if you are trying, because if you when you do something that comes from interrupt sources, it is usually a good practice to first of all stay there as little time as possible, do only basically what is necessary, and maybe in the while do most of the work. Here it's not something super complicated, so I can do that. And eventually, yeah, if you try to go inside, do something like go into stop mode as soon as you enter the an interrupt routine, as soon as you wake up from an interrupt routine and so on, you will find yourself that it's not working. And this is one of the things that ideally in your head makes sense, but it doesn't make sense to the guy that actually made the hardware, so it doesn't work.